Hey there, how's everybody doing today? Mr. Chu here with Tray Arithmetic. Let's talk about LCMs and LCDs and how they're related. So, in example 1, if I ask you to find the LCM of 3, 5, and 6, do you know how to do it? Well, if you don't, I recommend that you like this video because it helps me push it out to more people who will need help. And I also recommend that you subscribe. Down here in the corner will be a subscribe button to click on, then you can search all of my videos. All right, so if I want to find the least common multiple, there's 2 easy ways that I always taught my pre-algebra students. I know we're calling this tray arithmetic because it's just using numbers. There's no variables in it right now. If we were using variables and it really wasn't part of my algebra curriculum, my bare algebra, I would call it tray arithmetic plus because the plus meant pre-algebra. But this is just using numbers. So the very first thing we have to do is we have to write, one method is to write the multiples. So I take each number and write the multiples of them until the same number comes up in all 3. And then that is the common multiple. And then since it first appeared, it's least. So I have 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And then I just keep going. 12, 15, 18, 21, 24, 27, and I hope I'm far enough. If not, I'll get over here into this other problem. Now I'm going to change colors, and we're going to go to the 5. And we go until we have the same number on the top and the bottom. And since I can go to right here, let's just go to 30 here and see what happens, because I may have to go that far. So, 5 times 1 is 5, 5 times 2 is 10, 15, 20, 25. It's a good thing I went to that 30, because it looks like it's going to be 30, but we're not going to know that until we expand our multiples of 6. So 6 times 1 is 6, 6 times 2 is 12, 18, 24, 30, there it is. So anytime that I have that first number that comes out, that ends up being my LCM. So I'm going to take and underline each of these in red. And so we say that the LCM equals 30. All right, is there another way to do it? Yes. And it is a way that you really need in algebra, so I would always teach this in the pre-algebra. So let's look at a second method. The second method is to take the 3, the 5, and the 6 and write all their prime factors. Well, this isn't that hard because 3 is just a 3. That's the only prime. And you could have 3 times 1, but we want to write the primes right now. And then 5 is just 5. It's a prime too. But 6 is composite. What does that mean? It's 2 times 3. Okay? So now, you could always take and multiply 3 times 5 times 6 to find a multiple. But it's not the least common multiple. It would have been bigger than 30. So here's why. You take and circle what's common in at least 2 of them. All right? So then after you do that, you say, okay, I am going to find the least common multiple by multiplying everything that was not circled that's common. But if it's common, I only use that factor 1 time. So this wasn't common, the 5. Wasn't common, the 2. And then the 3 was circled. And then 5 times 2 is 10 times 3 is 30. Now you may say, oh no, that's harder. It's not harder when the problems have variables in them and when they're not, 2 of them aren't prime. Okay? All right, so 2 different ways. But once we have the least common multiple And if those are all of the denominators in a fraction, then we have found the least common denominator. So in example 2, I take that 3 and I call it 2/3. See how that's a denominator? The 5, 4/5. See how the 5 is a denominator? And the 6. Well, why do we need this? Because when you're adding and subtracting fractions, they have to have a common denominator. So I want you to see how this works because it's pretty amazing. So I've got my 2/3 plus my 4/5 minus my 5/6. Now I have to change them so they all have the same denominator, and I want it to be a least common denominator. So I have to find the LCD, which we know is 30. So we know it's going to be a 30. But what do you multiply 3 by to make it a 30? Well, count the greens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I multiply that by 10 over 10. Why? Because 10 over 10 is 1, and 2/3 will have that same fraction. So 10 times the 2 is 20. 3 times the 10 is 30. So now what do you multiply by 5 to get 30? Well, either you take 30 divided by 5 or you count in the black here. 1, 2, 3, 4, 5, 6. So I multiply that by 6 over 6 because 6 over 6 is 1, and you want an equivalent fraction here. So 4 times 6 would be 24. 5 times 6 is 30. And then the 6. Count the blue. 1, 2, 3, 4, 5. And then 5 times 5 is 25 over 30. Okay. So now let's go ahead. Since we've got a common denominator, we can combine the numerators. 20 plus 24, use the order of operations, is 44. Minus the 25 over 30, which ends up being 44 minus 25, which will be 19/30ths. And that cannot be reduced. And that is your answer. Okay, so you might be saying in your mind, yeah, but how could this ever be easier? Well, if I were to have something like 8, 12, and 18, this method here is so much easier because you would write the 8 as 2 times 2 times 2, the 12 as 2 times 2 times 3, and the 18 as 2 times 3 times 3. Then you circle what's in at least 2 of them. Well, that's going to be one of the factors that I use here. There's 2 of them, so I still circle that. It's one of the factors. So the only 2 that aren't circled are the 2 and the 3. So the LCM of these 3 numbers is 2 because I circled all 3 of them, 2 because I circled 2 of them, 3 because I circled 3 of them, and then the 2 times the 3. So that's 4, 12, 24, 72. Think about that. Taking the 8 all the way to 72. And that's why, in many cases, that is not the best way to do it. So I just wanted to show you that. So let me get rid of this so that we can give you your challenge problems. Remember, the challenge problems will be worked out. I'll be wearing the same shirt and hat. I'll do it right now, right when I finish this. And then I will post the link so that you can see them right now and see if you did them right or wrong. So write down these 2 problems. Challenge 1, find the LCD using both methods of multiples and prime factors of 4, 8, and 12. It's one of those where one may be a little easier than the other one. And then challenge 2, use the LCM to find the LCD and simplify. And just like I did before, the 4, 8, and 12 are the denominators here. So the LCM in this one will be the LCD here, but then you have to subtract those and then simplify it. So make sure you write these down on a piece of paper, pause, and then right up here will be a link to them. You can check your answer after you turn it back on and then click on that link and then watch the whole other video to see what the answers are. Down here will be a playlist of other arithmetic, tray arithmetic. If you don't, make sure you like this, give it a thumbs up, and subscribe to this YouTube channel. I'm Mr. Chew. This is Tray Arithmetic, and we just learned something about LCMs and LCDs. Let me help you. Watch my videos, and you'll learn the arithmetic. I'll see you next time in Tray Arithmetic.